Hi everyone, and welcome back to the course. In this section, we'll talk about how you can manage containers and Docker images. So the Docker images are simply a read-only templates that can be used as basis for launching containers. This means that everything that we're doing in the container has only effect inside it. So we don't make any modifications to the image that creates the container. So we should create a custom image for our future containers if you want to have one. So as you know, and I will here open a terminal, we can actually get Docker images by writing docker pull. This will download the image and save it to our device. So for example, if I want to pull Ubuntu, which is some Linux image, you can simply do docker pull Ubuntu. And if you click later, you can see that the image is up to date since I already have it in my device. But if you don't, it will of course start downloading. So you can easily save your image by writing docker save ubuntu-o and then let's write ubuntu.tar. Okay, so that will save your image, or it will actually pack it and generate a tar file with a desired name from you. So if you want to also create a backup for your image, you can do docker save ubuntu higher than sign and then backup underscore ubuntu.tar. Okay, and this will create a backup for your image. So if I hit here and check the Docker images by Docker images, you see multiple different images, and one of them is Ubuntu, as you can see here. And so all those images are a set of directories and files with specific structure. So each folder refers to one of the layers in the image. So within each layer, there are some files to reference that layer and a compressed file within the file system that will form the image. So when the image is extracted and constructed so that it can be usable, we can unzip the content for each layer in order to form the final image which corresponds to the base image. This will generate a file system that has content that is built and modified by layer. So you can look at the images as a permanently stored instance of container. So if the image is the class, then the container is the object. Or you can create multiple containers from a single image. So if you want to run and create a new container from an image, for example, if I want to create an Ubuntu container, you can simply do, so you see how easy it is to create a container just by writing docker create, and then for example, let's take one of the containers, let's say this one. Okay, run it, and you'll see that here we have a new container. And you can run it, you can stop it, you can basically do whatever you like with it. Okay, so you can also unpack the tar container that you have. For example, let's say if you use Ubuntu, if you remember, we created a tar file with it. So what you can do is to write tar tvf, okay, and then ubuntu.tar, okay, and this will unpack the file. So let's run that. And you can see that now our file is completely unpacked. So if you want to check the containers that are currently working, for example, you can simply do docker ps, and this will show you that right now we have only one container that is currently working. This is the one that we just created, that is from the image nginx. Okay, so you can see that from one image we can actually create multiple containers, and I will create one more just to prove you that. So let's do again docker create nginx, which will create another one and then another one. So right now, if I want to check docker ps, you see that we have again only one running. But if I activate the other instances of the containers that we just created and I write docker ps again, you see that now we're having three containers that have been created from the same image. So you can see how easy it is to create instances of any type of application and build container with it using Docker. So of course I will stop those containers that we just created so we can have a clear start for the next commands. So if you go back to the terminal, we can try some more things. So Docker layers are very much like Git configurations and store the difference between the previous and the current version of a particular image. So the layers use space, and the more layers you have, the thicker the final image would be. And Git repositories are similar to this. Git, for example, stores all changes between commits, so the size of your repository also increases with the number of layers. So when you request an image from repository, it downloads only the layers that you don't have to download to your machine locally. So for that reason, the Docker images use the same structure. We can see the layers of an image by simply writing docker image history and then the image name. So for example, if I do Ubuntu column latest, then you will see all the layers of that image. And you can do this for your other images too. For example, if I write here nginx and I hit that, you see how many layers we have here for that particular image. So another thing that I want to mention here are the image tags. They allow you to identify the versions of the images because the different versions are of course associated with their tags. So you can see here in this page, for example, the tags that are available for Ubuntu. So in that way you can download a specific tag image using the docker pull command. So for example, if you want to download the 18.4 version, you can simply go back to the terminal and write docker image pull and then the specific tag. So if I write Ubuntu 18.04, you will download specifically that version and specifically that layer of Ubuntu. And if I do now docker images, you will see that you have two Ubuntu versions. One of them is the latest, while the other one is the specific layer that we wanted to get. So this is why I'm keep repeating that images are pretty much layers that are mounted on the top of the previous layer of an image. So the latest is the highest layer. All layers in an image are read-only when a new container is created from that image, and we need to copy it in order to create container. So the original layered organization and copy on write strategy promote two major best practices for creating Docker images. And so there are two best practices, which are the aim of Docker to have minimalist images. And this is because Docker images get benefits from stability, security, and loading time when they are smaller. You can always install tools and containers if you need to solve problems related to development. On the other side, the base image can contain many layers and add many capacities. You can find official images for many distributions, programming languages, databases on the Docker Hub repository. You can simply type hub.docker.com. So this will be everything for this video, guys. Thanks for watching, and in the next one we'll talk about a quite important topic, which is how to build and manage the Docker file. Thanks for watching.